Lesson 1.6, Exploring Transformations. So if you kind of remember back from geometry last year, we looked at reflections, we looked at rotations, dilations, translations, basically grabbing a triangle usually and manipulating it somehow. So we're going to kind of start getting into graphs and how graphs can be transformed. We're not going to be doing all of the transformations we did last year, but we'll be doing a few of them. So let's get going. We need to be able to apply transformations to points and sets of points. So a little definition right here in the beginning is just that a transformation is a change in either the position, the size, or the shape. A translation, which is basically just a slide, moves each point the same distance in the same direction. So I just want to look at a couple scenarios here. And the big idea is trying to see how that it relates to the actual table. So we're going to look at the picture, we're going to look at the table and try to make the two kind of jive with each other. So our original shape, let's use this table over here on the right. Let me plot these points. -2, 4, and -1, 0, 0, 2, and 2, 2. And I'm going to connect these to make some sort of a kind of pattern here. So there's our graph, there's our shape that we're kind of dealing with. And let's do a horizontal translation. So horizontal basically means we're either going to be going left or we're going to be going right. All right, so let's start off here and let's move this shape, I don't know, let's move it right. Let's move it right 3 units. So just physically, when I'm actually doing this on here, I'm going to take every point and I'm going to move it to the right. You know, so this top left point is going to get moved 3 to the right. And this bottom of the V is going to get moved 3 to the right. And then the point on the x-axis is going to get moved 3 to the right. And then the point here at the very furthest right side is going to get moved 3 to the right. And I end up with this shape. So it should be the exact same shape, just move 3 to the right. Now, if you notice the points, the coordinates, all right, when we went right 3 units, let's see what happened to our x. Instead of, originally our x was at -2, 4, right here, which is that point. Our new point is now going to be right here at 1, 4. So what happened to the x was we actually took our old x value, and when we went right 3, we added 3 to our x coordinates. So that -2 just became -1. Now the y didn't change. We didn't move up or down. So our new x was -1. The next point, -1, we added 3 to it, we got 2. 0, when you add 3 to it, you get 3. And the last one moves over here to 2. So basically, our table just kind of changed a little bit, and our x's all got 3 added to them, but the y stayed the same. Now, I'm not going to go through a whole nother example, but if we wanted to move left 3 units, I could just take those x values and I would actually subtract 3 from them. So every x value, I would subtract 3. So looking at my original table, -2 subtract 3 would put me here, subtract 3 would put me there, subtract 3 would put me here, subtract 3 would put me there. Y's all would stay the same. And there's our new coordinates. And if I graphed it, left 5 up 4, left 4 up 0, left 3 up 2, left 1 up 2, and even without drawing the picture first, I could manipulate it or move it because I knew that horizontal translations affect the x number. All right, so the big idea that you need to take from here is that horizontal translations, you are either going to add or subtract the x value. And that's the big idea that you need to kind of put in your back pocket there. Now, vertical translation, I'm going to kind of speed this one up a little bit because I know you don't want to take notes forever. But vertical translation is going to control the up or down. And this is going to affect the y values. All right? So our y values are going to be changed. And if you add to the y value, you're going to go up. So if it's y plus, that means we're going to move up. And if it's a y minus, we're going to come down. So for instance, just really quick, I'm going to go back to my original, that original shape here in black. Negative 2, 4, had the 0, boom, boom. So we put our original on there. And let's say that I want to take all of those values, and let's say that we want to go down 5. All right, well, what that means is I'm going to take all of my y values, and I'm going to subtract 5 from them. So, my original table over there, these were the x's. All right, that was my x values. My new y values, I have to do that 4, and I have to subtract 5 from it. 0, I have to subtract 5 from it. 2, I have to subtract 5 from it. And the other 2, I'm going to have to subtract 5 from it. So actually, I screwed that one up. Because when I do 2 subtract 5 from it, that's going to put me at negative 3. And 2, another negative 3. So now when I put my new shape, left 2, down 1, left 1, down 5, 0, down 3, and 2, down 3. There's my new shape. And everything moved the way it was supposed to. It all moved down 5. So down controls the y, and you subtract. If you're going up, you're going to add. All right, so those are pretty straightforward. Up, down, left, right, no big deal. Those are translations. Well, now I want to look at reflections. Reflections are a little bit tougher. And a reflection is kind of like a flip. So let me put our original shape on here again. And I'll do this in black. So here, 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 here. Put him down, come up, come over. And I have all my points. Well, if I want to reflect across the y-axis, all right, the y-axis means I want to reflect, every point needs to jump across this line. So every single point, you need to jump across that line at 90 degrees. So for instance, if we're focusing on this point, if that point jumps across the green line at 90 degrees, the new point is going to be right here. So it looks like my negative 2, negative 4 has now become positive 2, positive 4. All right, so this is kind of my new chart. This bottom point, if it jumps across the line right here, it's going to jump right over there. So that point, negative 1, 0, is now positive 1, 0. And this point is kind of unique because it's right on the line, so it doesn't move anywhere. It stays right on the line. So 0, 2 stayed 0, 2. It didn't move. And then my last black dot, which would be this dot, is on the right-hand side of the line 2 units. So it's going to jump over here to the left side 2 units, which is at negative 2, positive 2. And now when I reconnect the dots, I basically get the same shape, just kind of working in the backwards direction. Now, what really happened? If you notice, the y values stayed the same. Nothing really changed. But all of my x values, the only thing that happened to the x values is they became the opposite. All right? They became the opposite. So in general, when you reflect across the y-axis, we can say that every x comma y point basically becomes the opposite of x comma y. Y stay the same, but x's become opposite. Not always negative. You don't really want to view that as a negative sign. You want to really view that as the opposite of x. Because some were positive, changed negative, some were negative, changed positive. Now, same shape on the x-axis. So I go to my OG, my original shape here, boom, 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 boom. And so we look at, this is the OG. This was our original. Well, if I want to do a reflection across the x-axis, that reflection means it's going to mirror across this line. All right? So all of my points need to jump equal distance at 90 degrees across that line. So this top point up here is going to jump all the way down right there. So that new point is at -2, -4. And the next point is on the line, so it's going to stay on the line. This little fella right here is going to jump down 2 units, so he'll be at 0, -2. I guess I should have left this point stayed the same. It didn't move. And then finally, this dot over here, 2, 2, jumps down to this position, which is 2, -2. So kind of similar to what happened when we reflected over the y-axis. This time, all of our numbers that were the x value stayed the same. The left-right didn't really change. Everything just changed position on the y's, and they became opposites. So in this situation, x's stayed the same, y's became opposite. So when you're reflecting across the x-axis, for every point xy, the x is going to stay the same, and you're going to have the opposite of the y value. All right? So I guess a way to kind of remember that is just whenever you reflect, whatever axis you reflect across, that value stays the same, and the other one becomes opposite. All right, now we need to get into, these are a little bit more difficult, but we need to get into what's called stretches and compressions. And there's 2 ways to kind of, and this chart has a lot of information, so I'm not really going to try to throw the whole chart at you right now. But if we think about horizontally, all right, so let's kind of focus on the horizontal column. So if I have some sort of shape, sorry about that. Don't know what happened there. It just kind of yanked around on me. So if I have some kind of shape, and let's say that, this is kind of our standard curve. And if I want to do a horizontal stretch, so a horizontal stretch means every point is going to be pulled away from the y-axis. So that means if this was like made out of iron, a horizontal, that means left and right direction, I'm going to stretch it out. So the stretch is going to pull it kind of out and make it a little bit fatter. So the blue represents a horizontal stretch. So I'm yanking everything out away from the y-axis, all right? And then if I'm going to compress it horizontally, so that would be this box down here, if I kind of start with my standard thing, and I compress it horizontally, that means I'm going to apply pressure in, all right? I'm going to press this thing in towards the y-axis, which is actually going to make it more narrow. It's going to kind of smash it in there and make it a little bit skinnier. I kind of think of this as like fat and skinny. So my parabola got fatter, that way my parabola got skinnier. Now, if we're talking vertical, if we're looking more over in the vertical column, the vertical column means that I'm pulling away from the x-axis. So I'm thinking of the x-axis as being like gravity, and I'm pulling away in one direction or the other. So I start with some sort of a bowl. Maybe I start with just something like this. Well, if I'm going to do a vertical stretch, that means I'm going to pull it away from the x-axis. So every point's going to get kind of yanked away, and it's going to look something like this. It's going to kind of go, and it's going to kind of get skinnier. And it'll be easier to see once we have some actual numbers on here. And then the last one is when you compress it vertically, that means you're going to push towards the x-axis. So I have this bowl, and I'm going to push towards the x-axis. So I'm going to apply pressure from these 2 directions. All right. It may end up doing something like this. It's going to flatten out, but then it's also going to kind of change position a little bit. Notice the big idea over here with the horizontals. the horizontals, the vertex, pretty much stayed the same. You were just applying straight pressure inward, and it really didn't do anything. But over here, when you're looking at the vertical issues, our actual vertexes, they kind of shifted. They're not in the same spot. And it kind of affects whether we're pulling or changing the y coordinates or the x coordinates. So let's just jump into an example. I think that may be a little bit easier to kind of deal with. So it says use a table to perform a horizontal compression of y equals f of x, which we have graphed over here to the right. So we need to do a horizontal compression. So that's the key factor here. Horizontal compression by a factor of 1/2. And then we're going to graph it over there and identify some important points and make a little table. Well, let's start off with what we have. So I want to make an XY table of where we are currently. And let's just get some important points. Like I think this dot is probably important. So that's at -1, 3. This dot's probably pretty important. That's at 0, 0. I'm trying to find lattice points. A lattice point is where it crosses perfectly at a corner. So then we have this point at 2, 2. And then we have a couple other points. I don't know if we need to put both of them. Maybe I'll just put that one at 4, 2. If we wanted to, we could probably include this one. Maybe he doesn't want to feel left out. And we could put him in there. So we have this red function, this red f of x. And we need to do a horizontal compression of y equals f of x. So let's go up here to the chart and let's look at the horizontal compression section. So horizontal compression is in the lower left. And it says we're shoving everything towards the y-axis. And what we need to do is we need to change the x-coordinate by that factor. We need to manipulate the x numbers by that factor. So if I come back down, right here, we need to manipulate horizontal compression. So we need to shove everything in horizontally. So we need to smash it kind of from this direction. So we're going to affect the x's. So we need to multiply the x's by, and then in this problem they want us to multiply all x's by 1/2. All right? So let's compress it. Let's smash it in by a factor of 1/2. So if I make my new chart, my y's are going to stay the same, but all of these x's right here, I'll just write it right next to it, all of these x's are going to get times by 1/2. So a -1 times 1/2 is that number. So now my new point is at -1/2 up 3. So my new point is at -1/2 up 3. So I'm now right there. And if I multiply this 0 by 1/2, well, that's 0, 0. So nothing really changed there. So there's my second point. If I multiply the 2 by 1/2, I get 1. So now I'm at 1, 2. And if I multiply the 3 by 1/2, I got 3/2. Or if it's easier to think of as 1.5, I got a 1.5, 2. And then the 4 times 1/2 is going to be 2, 2. So it kind of, my shape basically just comes in here a little bit tighter, bends up there a little bit faster, and then kind of takes off that way. So you can see that we got smashed, we got compressed horizontally. We are applying pressure, like parallel to the x-axis and just pushed it in there further. Now, if we were going to do a horizontal stretch, we would have multiplied by a number that was bigger than 1, because then all of our x's would have spread out a little bit further. So I know this is kind of tough to think about, but compression is basically your x's are going to get smaller, so you need to multiply by a number smaller than 1. You're going to multiply by a fraction. All right, let's go down to the next one. Let's check it out. All right, so next example, it says we need to perform a vertical stretch by a factor of 2. So vertical stretch, that means that I'm going to be stretching vertically. I'm going to be pulling it away. So we're basically stretching away from the x-axis. We're going to try to kind of stretch it out up and down. So we're going to be affecting the y values. The y values are the ones that are going to get changed. So we need to do it by a factor of 2. So let's see what we got going. Well, we still have our same table. And our values here were -1, 3. We had 0, 0. We had 2, 2, 2. And we had 4, 2. I'm going to leave the other point out just to speed this up a little bit. So if I want to do a vertical stretch by a factor of 2, that means I'm going to need to multiply the y values by 2. So kind of create a whole new column here, and we need to times all of our y values by 2. So that 3 will become a 6. The 0 stays 0. 2 times 2 is 4. 2 times 2 is 4. And we now have some new points. All right? So our new points, and it looks like we're going to fly off our grid a little bit. We're going to go left 1, up 6, which is going to be right there. And then we're going to be 0, 0, which is right here. We're going to be 2, 4 over 2 way up here now. And then we're going to be another 2, 4. Or actually 4, 4, I mean. So up here, up here. So now we're like, shoom. It's kind of rounded. So it almost kind of looks similar to the horizontal compression. It kind of got smashed in. But that's what happens when you stretch something vertically. When you stretch it up, it's going to kind of come in a little bit and be horizontally compressed. I'm going to kind of go off the grid a little bit and see if we can kind of make some sense of this. So we have a coordinate plane. I'm just going to make up a typical shape. Let's just do a little parabola that's got points right here, over 2, up 4, over 2, up 4. All right, and we're just going to kind of make a little one just that big. And let's try to kind of go through the 4 phases. So our typical table here, if I were to map these points out on a table, our points, our xy's, so this is the OG, is at -2, 1. We are at -1, -2. We're at 0, 0, no, 0, -3, I should say. Over 1, down 2, and over 2, up 1. So there's our points. Well, let's kind of go through the 4 different possibilities. So if we want to do a horizontal stretch, all right, so horizontally, side to side, we're going to stretch this thing. We're basically yanking it out in both directions. Well, all of our x coordinates are going to be bigger. So here we're going to be multiplying. We're going to multiply x by a number that's greater than 1. So our number is going to be greater than 1. You know, so for instance, if I did a horizontal stretch by, let's say, a factor of 2, all of those x numbers are going to become bigger. You know, my x is now going to be -4, 1. It's going to be -1, -2. It's going to be, well, 0 doesn't really change. Make that a -2. And x is going to become +2. And the next x is going to become 4 because I'm multiplying all the x's by a factor of 2. The y's pretty much going to keep doing their thing, staying in here. So if I actually do it out, I'm going to go over 4, up 1. I'm going to go over 2, down 2. 0, 3 stayed the same. 0, -3, still chilling right there. Right 2, down 2. And right 4, down 1. So notice that my parabola got kind of yanked out. And actually 4, +1. Thought that looked kind of goofy there. 4, +1. So my parabola, or my bowl, got kind of stretched horizontally. It got pulled outside like that. So now let me get rid of him. and let's just compare that with a horizontal compression. So if I'm going to horizontally compress this thing, all right, that means I'm going to smash it in, which actually means my x values are going to get tighter. They're going to get smaller. So I'm still going to multiply by x, but this time my number is going to be a fraction. 1 doesn't change it, but if you're less than 1, you're going to make it smaller. So let's say I want to horizontally compress it by a factor of, I don't know, let's say 1/3. All right, I may have to do some estimating on here. But let's do it. So if I multiply all the x's in my chart by 1/3, I'm going to get -2/3. I'm going to get -1/3. I'm going to get 0. I'm going to get +1/3 and +2/3. So I was just kind of multiplying by all these numbers in the chart. The y's, nothing happens. They all just stay the same. -2, -3, -2, and 1. So let's do this. Left 2/3, up 1. So that's going to come here. Left 2/3, up 1. So about, I'm just kind of putting it about where it is. Left 1/3, down 2. Left 1/3, down 2. 0, -3, kind of stays the same. 1/3, over 1/3, down 2. And over 2/3, up 1. So this is now what my shape looks like. I have horizontally smashed it in. Notice the vertex didn't move. The vertex stayed the same in both scenarios. So when you're messing with things horizontally, it's just a simple smash from left to right. Now, go over here to the vertical. If I do a vertical stretch, all right, well, vertical stretch means I'm pulling in directions up and down. So I'm affecting the y values. And the y values are actually going to get bigger. They're going to get more extreme. So I'm going to multiply the y's, and my number is going to be bigger than 1 because it's going to get stretched out, going to be bigger. So let's kind of do that. And I think my table here is going to kind of get in the way. But let's say we want to do a vertical stretch by a factor of 2, let's say. So on my table, I have my normal numbers here. Everything, all the y's are going to get distorted or stretched by a factor of 2. So my new table now, my new xy's, the x's all stay the same. -2, -1, 0, 1, 2. But my y's are going to get multiplied by 2. So this number gets multiplied by 2. This number multiplied by 2. By 2, by 2, and by 2. And now when I plot that out, left 2, up 2. So that one got stretched. Left 1, down 4. So that one got stretched. 0, -6 actually came way down here. 1, -4 comes right here. And then 2, 2. So notice everybody got stretched further away from the x-axis because I'm pulling it up and down. So now my new graph kind of looks like that. So I got yanked vertically in the up and down direction. And then lastly, I know this is getting kind of redundant, but I just want to show you all the possibilities. Lastly, when I do a vertical compression over here, so vertical compression, well, that means I'm smashing things inward. So that means my y's are getting smaller. So I'm going to be multiplying y's by numbers that have to be less than 1. That's how you make them smaller. So I'm smashing them all in. So let's say we do a vertical compression, I don't know, we'll just make it easy, by a half. Everything's getting smashed vertically by a half. So that means all of my y's, all of my verticals, are getting shrunk by a factor of a half. So all these numbers over here need to get multiplied by 1/2. So I have a half, I have -1, I have -3 halves, aka -1.5. Negative 2 times a half is negative 1. 1 times a half. And all of the x's stay the same. Let's plot that. So left 2, up a half. Left 1, down 1. 0, negative 1.5. 1, negative 1. And then 2, positive 1/2. And my new shape kind of looks something like that. So everything got smashed inwards towards the x-axis by a factor of a half. So all the points kind of, it's almost like gravity just grabs them and yanks them half the distance towards the x-axis. All right, I know this was kind of overkill, but hopefully it'll help you out when we get doing some problems. But really, it's hard to learn it just from watching. You kind of got to get your hands dirty and get after it. See you.